Okay, here we're going to learn a little bit more about the oral cavity, looking at some of the details that occur in our mouth in relation to the digestive system. Starting with functions of the oral cavity. Well, there's sensory analysis of material before swallowing, recognition, kind of determining texture, mechanical processing, which occurs through the teeth and the surfaces in the oral cavity. Lubrication is occurring with mucus and salivary gland secretions. And there's some digestion. It's limited, but mainly carbohydrates and some lipids. Salivary amylase is one of the key enzymes that's produced, and that is starting the breakdown of carbohydrates. If you ever had a cracker and just kind of kept it in your mouth, eventually it will kind of break down, turn into mush, and ultimately liquid. If you did the same thing with like a piece of gum or something high in fats, that same process will not happen because you only have enzymes specific to carbohydrates and some minimal on lipids. Now, breaking down the food in the mouth, many vertebrates have teeth that allow for chewing, mastification of the food. Now, we're going to see a carnivore or herbivore and an omnivore. Looking at incisors, canines, premolars, and molars, all color-coded appropriately here. In the carnivore, those that only eat meat, you see the noticeable incisors in the canines are very pronounced here. That'd be an example of our tiger. Carnivores have pointed teeth. They're adapted for cutting and shearing. Herbivores, those plant eaters, such as the deer, those have flat teeth. Here we see our molars and our premolars, well suited for grinding of plant cellulose, help to kind of mechanically break down the very complex cellulose. Also notice their incisors and canines are in a very small amount here. There's actually kind of a gap here in their teeth, because we have a lot of the premolars and molars for that breakdown. Then our omnivores, these have kind of the teeth of the carnivores in the front, and kind of also the teeth of the herbivores in the back to allow them to eat both meat and plant materials and be able to efficiently break them down through the mechanical process. Continuing on to the tongue, the superior surface of the tongue actually bears three different types of papillae. We have the filiform, which is to give the tongue the roughness and provide friction. You kind of want friction in the tongue so you can be able to move that food around. Fungiform is scattered widely over the tongue and give it that reddish kind of hue as we see here. Circumvallate is the V-shaped row in the back of the tongue. That's kind of weighted towards the back section there. And then our sulcus terminalis is the groove here that separates the tongue into two areas. We see the anterior two-thirds residing in the oral cavity, and the posterior third here residing in the oropharynx, which is important when we're starting to ingest our food as it begins its way, or its path, through the digestive system. In the mouth, the tongue mixes the food in solution called saliva. The saliva moistens and lubricates the food. Contains amylase, which remember is an enzyme that's important for the breakdown of starch. Starch is a collection here of glucose molecules all linked together. Amylase here is considered like the starch clipper, breaking down. A disaccharide of a polysaccharide of cellulose could be maltose, and the monosaccharide of maltose would be glucose. Disaccharide being two glucoses linked together, monosaccharide being one here. See again, poly, di, and monosaccharides, amylase breaking down our starch, maltase breaking down our maltose. So remember ASE at the end, important for identifying potential enzymes. In the mouth, our salivary glands are controlled by the nervous system. You can see where they're located right here. Continuous secretion of about 0.5 milliliters per minute keeps the mouth moist, and in the presence of food, this triggers an increase in the secretion rate. The reason why we want that increase in secretion rate, we want to be able to lubricate the food as it starts to enter the digestive system. We also want an increased number of enzymes to start breaking down some of those carbohydrates. Lastly, the bolus, as a ball-like mixture of food and saliva that forms in the mouth during the process of chewing. We have that bolus forming, so that's going to be turned ultimately into chyme, and that chyme will be broken down into nutrients, which will be absorbed, and all the leftover material will be excreted from the body in the form of feces. Once the bolus reaches the stomach and mixes with the gastric juices, it becomes chyme. So keep in mind it's kind of the same collection of food, but depending where it's located and what it's mixed with, that will change its name. So if you're looking for identifying certain areas, that same thing that was called a bolus up here, we call chyme once it reaches the stomach and mixes with gastric juices. Further digestion and absorption, and eventually will be discharged again as feces.